So, welcome to Blueprint Plus Plus, a new webinar series where we interview leading thinkers at the intersection of business and technology about the trends taking shape in the world of software and AI and best practices to get ahead. Today's guest is Cassie Kozyrkov, CEO of Kozyr and former chief decision scientist at Google, the woman who oversaw their AI transformation. Thank you so much for joining us, Cassie.
I'm so excited to be here, Chris.
Great. So, Cassie, I'm always curious to hear about people's stories. So maybe you could start with a little bit about your background and how you got here.
I trained as a statistician. I would say that I'm a recovering statistician. Also studied neuroscience, economics, and psychology. And those decision disciplines, paired with the data disciplines, all oriented around how people actually make decisions under uncertainty and how we could do that better and how we could do that with better tools is what inspired my journey.
That's great to hear. And I'm just curious, at Google, chief decision scientist, what does a chief decision scientist do?
All about making our data science and AI efforts more effective. So think of it as you might think of a chief data scientist, but with a little more orientation on, again, decisions, purpose, and leadership.
Makes sense. Well, moving to AI seems to be on the tip of everyone's tongue. And so my question for you is, what does it mean for technical teams to be AI first?
AI first is two attitudes. The first attitude is asking yourself, not about AI, but what could be better around here? What used to be impossible, which, if it were now possible, would actually help us move towards the future we want to build. And then realizing that AI could just be the way that you get there. Realizing that AI puts so many impossible things on the table. The other AI first attitude is realizing that the world is going to change so quickly, is already changing so quickly because of accelerating technology, because of AI. And so if you're expecting to do business the way that you've always been doing business, to rely on exactly the same traditional solutions you've always relied on, well, that is an extremely big gamble. When organizations are trying to use AI to pinch yesterday's pennies, I think that is such an unambitious way to approach AI, to try to do exactly what you've been doing all this time, but maybe a tiny bit more efficiently or with a little bit less headcount. Instead, realize that the world tomorrow is going to be different from the world today.
You helped Google become AI first from within. And so as you went through that transformation, what were some of the cultural signals or rituals that told you that the shift was actually taking root?
The biggest and most important one, at least from my perspective, is leadership participation. Look, something else that bears caveating here is when you do innovation, your strategy is hope. Innovation has a lot of hope involved there. Core to innovation is you've never done this before. You have no idea what's actually going to work. So innovation demands waste. It demands that you're able to say, I'm just going to try some stuff. And maybe I get something out of it, maybe I don't. And maybe I've wasted all the time, but at least I've now got a culture of innovation and I'm devoting some effort to try. So I'm not against having a little bit of hope as a strategy, at least towards innovation. But where you have to rely on something, where you want to drive it based on what you already know is worth doing, then folks who start with, well, what's the vision, what's worth doing, have to be driving. And so the big cultural signal are those the folks that are present and participating when it comes to AI from the beginning? Or do we have folks chasing a bunch of tools for the sake of the tools? Again, having some tolerance for innovation. It's something that Google has done beautifully. I really admire that they're willing to have some waste, and they have some tolerance of pretty much everybody, even whether you're in the engineering side of the house or not, has some opportunity to try to contribute. So instead, when you see people coming to AI from the other participating roles, starting with leadership, UX, all the way through to reliability on the other side, you see end-to-end projects that have multidisciplinary teams who are all conversant in what is our particular role in AI, how do we contribute, and how do we make sure that there is a vision and then that vision is served. That's the big signal. And then, of course, the other signal when you're getting started, if you think of baby steps, if you wanted to look at overall in an organization, a large organization like Google, you would look for signals that you suddenly get things that wouldn't have been able to exist without AI. So in a statistics sense, you're not estimating anything. You are looking at pure existence. It didn't exist, now it does exist. And you count them up when you start seeing hundreds, when you start seeing thousands of things you couldn't have had before AI. That is an enormous signal to you that you are integrating opportunities. And when it comes to generative AI is a funny beast because of all the endless ways in which things could go right. We're used to measuring things in terms of, did we get the thing we were aiming at? Like that's traditional measurement. That's also traditional AI. We have a notion of minimizing errors. That means we have a notion of error, and typically an easy one. And we're just saying, well, how do we measure the number of times that we did the thing we wanted to do versus we didn't? What's the distance there? So it's a very one right answer, past. But our future with generative AI is we're really looking at endless right answers, not just one right answer. What does it mean to create effective code? Is there just one way? Well, for a very tiny problem where there is only one way to solve it, there is a notion of a right answer. And for a gnarly complex problem, there are many, many different ways with many, many different trade-offs. So who is then responsible for figuring out which of these is sufficiently good? Where do we draw the cutoff? Again, the big signal is that folks who are participating in talking about what good enough looks like are the right folks in the organization, the ones connected to purpose, not just to technology.
Yeah, some really good points there. And so if I think about sort of the types of users and teams that are AI first, what are the productivity gains you're seeing from these individuals and these teams? And what are they doing different from the other teams that aren't AI first in your mind?
When you think of AI for individual productivity, whether it's your own or individuals on your team, that is a very, very different game from automating things at organization scale. And it is rather unwise to do at-scale transformation thinking of it still with that individual productivity paradigm. In fact, one of the ways that executives can make themselves pretty dangerous to an organization is they go and they find some large language model, they start playing with it, they realize that they can do cool things. They can get emails written faster, they can use voice mode, whatever it is. And they realize that as an individual leader, wow, obviously this is so transformative, it's cutting out so much drudgery, right? All the things we want. And we want that paradigm as well, right? That individual productivity paradigm, whether it's the leader or their staff, hopefully both. We want it, but that leader then can miss just how different it looks when you think about automation at scale. What data gets you is it gets you superhuman memory and superhuman attention. And what that allows us to do is it allows us to automate where we cannot come up with the solution by thinking through the steps, and where we would, with traditional programming, have tried to hold everything in memory, in human memory. First, I need the computer to do this, then that, then that, then that. We can only approach tasks where that fits in our heads in that manner. So what about all the situations where it's just so hard to figure out what the solution should look like? Classics. If you think about image recognition, you've got those pixels. How would you express the formula for, I don't know, your face under any angle, any lighting, any condition? You somehow know it's you when someone shows you a photograph, but you don't know how you know. It's very, very hard to write those steps out. With data, we are able to automate a level of complexity that you cannot automate otherwise. And I want to really emphasize, sort of hold this point for a little bit. Because when executives say AI adoption, I want them to hear complexity adoption, for better or worse. Complexity adoption is fantastic when your problem has a solution that is too complex to solve any other way. But it is not a good thing in and of itself when the solution is actually simple, and now we are going to complexity unnecessarily. The leaders might not have good connection to, well, what are the technical trade-offs that we're making as we try to pursue one or other purpose. That's one of the gaps that you really have to close. But always come back to the reason that we are using very complex tools is that there is no other way to solve what we need to solve.
You know, when I talk to a lot of CTOs and leaders, you know, they're going through the teething pains of AI adoption. They're saying, what should I do with it? And they're running into all of the same problems you mentioned, right? Which is they see the technology and they're very keen to apply it to anything in front of them, right? They don't have a clear vision of how they're going to use that technology. And vice versa, they have a clear technology. I mean, they have a clear vision, but they don't have a clear idea of how the technology works. And so I'm just curious, as you consult with leaders around the world, what's some concrete advice about, you know, what are the first steps these people can take? Because often the question I get is, Kris, I get it, and what you're saying makes sense to me. Give me some baby steps. What should I do first?
Unfortunately, when it comes to leading, unfortunately, when it comes to purpose, baby steps are hard. But look, if we want quick wins, think about what's actually frustrating you about how your processes work today. What do you take for granted? Where are the time sucks, the resource sucks? Because maybe those don't need to be there anymore. And if we are still thinking of we're doing things today the way that we've always been doing them, and that's why we will continue to do them that way, well, maybe then the first attitude change is letting go of that. Saying, well, what if I could just rebuild everything that my team does from scratch? How, if I dreamed a little, what would I want to be different? And then asking, is that technically possible? Now we have the conversations with technical teams about what can actually be done.
Totally agree. You've spoken about the AI trust gap before. And so when we think about where the gap is broadest in software engineering, how do you think about that?
Oh, several. Let's start with trusting AI at all. Which, you know, maybe this is the statistician in me. Maybe, Kris, you have similar feelings as a statistician, recovered or not. And I think that just don't trust. Zero trust is not just for cybersecurity. Don't trust anything that has not earned your trust. Why would you expect that any complex technology, and now that we're realizing we're dealing with complexity adoption, anything where we've had to rely on data for automation is about complexity. When we're dealing with complexity and when we're dealing with fundamentally unreadable and inscrutable things, and not because somebody is hiding how the model works, but even if you take some open source or open weight model and you begin to read those billions of parameters, you're going to understand nothing. You're going to understand nothing because it overwhelms your human mind, your human capacity for comprehension of all that complexity. And so you don't trust by attempting to read the solution. We say, oh, I want to trust the thing because I want to understand how exactly things work in there. You need to let go of that. You need to let go of that and remember that you already know how to think about this kind of thing with humans. So as a recovering neuroscientist also, I'll say that neuroscience is a beautiful discipline. It attempts to figure out how the brain implements all kinds of things, including decision-making. My particular neuroscience major was neuroeconomics. There is such a thing, for those who didn't know, the neuroscience of decision-making. And at the end of that, all we get is broad strokes understanding. What we don't know is actually how the brain actually implements decisions. And you have no grasp of it. But that doesn't worry you. Instead, you appreciate that there is complexity. Understanding the task is easier than understanding the model. And here, model could be AI, or it could be the human brain. And trust is partly then achieved through testing, as we do with humans. But even then, because we're dealing with complexity, don't trust. Don't even trust the test. The test is unlikely to have covered the same level of complexity with the requisite amount of data for covering that complexity to actually give you a real sense that you can trust. So instead, on top of all that, wrap everything in safety nets so that even if things go wrong, you can mitigate problems and you can prevent or avoid them. And so what you would trust instead is less the brain, but rather the structures within which that brain is placed. And who places those structures? How we keep ourselves safe is really by placing tools and solutions into situations and with supporting structures that render them safe. Eventually, some human has to make the judgment call. When there is no one right answer, that's where the most difficult work actually exists. And so when we look in the engineering space, we also see that more seasoned engineers typically get more respect for the pieces that are the softer skills, the judgment skills. When we think about architecting a system, it is much easier to do that, again, within a very constrained decision problem where we already know why we want, where we already know what we want and why we want it. The much harder thing is when we have options and we have to apply judgment and create those constraints ourselves. So the more seasoned engineer, the one who is closer to leadership, the one who is applying judgment, that engineer is also much more likely to point their tools in a direction that's worth pointing them. They're also much more likely to keep thinking about whether what they're getting is actually what would be useful and valuable. More junior folks, though, they might get stuck on face value things that look like they have one right answer, but only because we didn't interrogate what the conditions were that set us up for having a one right answer kind of framing. And so when we look at this growth from thinking that we're actually dealing with one right answer situations to realizing just how many options there actually were, we also see that if we're taking flat metrics, like how many lines of code were we able to output, not were these fit for purpose, and what was our purpose, and how abstract, at what level of abstraction are we working with this purpose? If we're just trying to create more lines of code faster or save time in a flat way, then we get a kind of alignment problem within engineering itself. This is why we hear about junior engineers potentially creating more work and more technical debt when they use these tools that put potentially poor judgment on steroids, whereas the more seasoned folks who are more connected with the why, when they use very, very powerful tools, then they actually get aligned value out of it.
I think that's really good. And speaking of judgment, I recently read in your Substack about vibe coding, and obviously when I talk to CTOs and team leads, there's this perennial question now, maybe not perennial, but whatever the monthly option of that is, where people are saying, to vibe or not to vibe, right? Vibe coding is this thing, right? And so if you put yourself in the shoes of a CTO or let's say a team lead, and you have to make a choice, what are you telling your team? Are you telling the junior engineers it's okay to vibe code, or are you telling them, yes, but?
If it doesn't matter how well something works, then what harm is there in vibing? If we are just playing and seeing what's possible, and we're not thinking about deploying anything we have to rely on, what harm is there in vibing? When we have clarity and we have expressed very clearly that we have something important, and we might not be able to tell whether we achieved whatever it is that we're hoping for, we see that the dangers of vibe coding go up a whole lot. So to talk to CTOs or team leads, I would say the question isn't to vibe or not to vibe, as much as Shakespeare might have wanted us to think that. Instead, the question really is about what is at stake. Can you afford to inject less clarity and less control into your procedure? Are there the safety nets that could hold all of this together so that if your vibe-coded solution wasn't very good, that you then end up performing well anyway? Or do you have the ability or expertise on your team to read and understand and not fall asleep at the wheel? Right? Falling asleep at the wheel, that human piece is a very, very important one as well. There is a huge difference between, you'd say, okay, I need to write 2,000 lines of code approximately, and it's so much easier to ask an automated tool to help me out with that. And then I go and I read and I check and I, unit test everything that I need to unit test. That sounds good until maybe, as again, the more naive or junior person here, you trust it. You trust it for the wrong reasons. You trust it without checking it. And then instead of saying, well, the writing got done quickly, now, it's faster to check it than to write it, so that's how I'm going to do that. You don't even check it. And now you take this whole thing and you plug it into production, and what could possibly go wrong? So really asking yourself, how do I guarantee that I've got people checking it? How do I guarantee that I have stated clearly what I'm trying to achieve here? That I know what it means for it to work, that people aren't asleep at the wheel, that if I'm going to rely on this, nothing is going to go wrong. And then you can also start to break down what parts of the procedure lend themselves better to the automation of language. I mean, documentation, for example, is a pain in the butt. Documentation is a favorite. That's not code that's actually running. That is signposts for future you and your colleagues not to hate current you for having put some opaque thing in that then you need to puzzle out. If you can accelerate your writing of the documentation, how fantastic. Such an easy win. That's a very different thing from potentially putting in code that might have very different expression, different levels of complexity that might end up ballooning out with nobody having checked it. So it's really not about vibe coding or not. It's about what makes us more excellent at whatever we're trying to do.
Yeah, and one of the things that resonated with me when I read your Substack post was the example you gave of validating a country. So you have a user input form, and the user has to input the country, and yeah, you could hook it up to a huge LLM and check whether or not that's a valid country. But in the good old days anyway, you could create a finite list and do a search pretty quick, pretty cheap, and perhaps easier than using a big LLM.
Right. So perfect. So thank you for bringing that up again. This comes back to the complexity question. If you are able to do something without AI, you should do it without AI. All right, let me give you a quick rule of thumb there. If you could have done something cheaply and easily in 1995, you're not looking smart using AI for that. But what is it about your task today that without AI, you're coming up against problems? And think of what you are doing with your people resources as also about cognitive resources. Are you using people's judgment, people's decision-making, people's creativity for whatever the best possible purpose is? If you get stuck on, well, here is my particular task, and I am used to being careful and pedantic about this task, should I or should I not use AI on this? You're also missing, well, what is the opportunity cost of optimizing this? Maybe I can afford some error rate on whatever this is. Maybe I can even afford to have my quality go down overall on this process if what I get out of it is that I can now do something else of higher value. So it could be that your vibe-coded solution is worse than your traditional solution. But is the difference small enough that, and the time freed up large enough, that what you could then spend the human's effort on is something much, much better? And maybe it's okay. Maybe it's okay then that the quality goes down.
Yeah, that makes a lot of sense. So you've warned executives that if they outsource their understanding of AI, they're making the same mistake that execs in the 90s made when they outsourced their understanding of the internet. So question to you, in 2025, what's the minimal viable AI literacy an executive needs to have?
Yeah, so what do we mean by this understanding again? As we said earlier, understanding how the optimization math works, understanding what those billions of parameters in a large language model are doing, that is not the understanding that I am worried executives will outsource. What you shouldn't be outsourcing is what it actually means to bring in attention, memory, complexity, language, action at scale into an organization. To think that somebody with technical expertise is more qualified than somebody with the right level of view, the right level of connection to outside reality, not just technical reality. You need to understand the nature, at least in broad strokes, of what you're bringing in into your organization. And that is not just the model, that's everything else that it sits with, including how your people are going to interact with it.
So what's your biggest prediction for how AI is going to change work in 2026?
I think that in 2026, a lot more leaders will be thinking about whether or not their office spaces, their physical environments, are well suited to how work is changing. For example, with voice mode. Voice mode is an underutilized but rising in popularity approach to getting things done, because we tend to, at least I know this is true for me, I know it's true for a lot of people, it's not true for everybody, but a lot of people tend to think closer to the speed of their speaking than to the speed of their writing. And so if you're able to communicate what you need done, whether it is for vibe coding or for anything else, at the speed of thought, you'll get more productive. But then think about how an office space where everyone is talking into their phone or into their laptop, like a bunch of maniacs sitting closely in these open plan offices, it'll be very weird.
Right.
So will we think about redesigning? I think maybe past 2026, we will start seeing a lot more natural interaction modes coming into how we work, and physical spaces redesigned for them.
That's fantastic. Well, thanks for all your time, Cassie.
Thank you. It's been lovely to be here.
If this conversation has gotten you more curious about AI, make sure to check out the page below, where you can learn about JetBrains AI solutions. JetBrains IDEs enable you to select the model, an agent, or agents that work best for you and your team, so that you have complete flexibility to use a wide variety of AI tools at once, without vendor lock-in. You can also check out our coding agent, Junie, which creates high-quality, trustworthy code so that developers can be happier and more productive. If you like this webinar, subscribe to future episodes and check out our other series, Hands-On. Thanks for tuning in to Blueprint++.